This is class 34 of my arithmetic course. Today we're going to finish tying up loose ends. In the last class we started tying up loose ends, so we're going to finish that today. So this course, or this class is entitled A Few More Things, Part 2. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now we're going to start with pairs of fractions. You can see we have a pair here and a pair here and so on and so forth. And we're going to determine which fraction is bigger in each pair. Now we can't tell which fraction is bigger because we're counting different size pieces. We're counting fifths and sevenths. Now if this fraction were 1/5, then it would be pretty obvious that this fraction is bigger. But we don't have 1/5, we have 4/5. So it's hard to tell which fraction is bigger. So what we have to do is we have to use the fundamental principle of fractions to change the form of these fractions so that they have a common denominator. And then we can compare the fractions because the pieces that we'll be counting will be the same size. So we're going to multiply both sides of this fraction by 7, and we get 28 over 35. And multiply both sides of this fraction by 5, and we get 25 over 35, and now we're counting the same size pieces, 35ths. We have a common denominator. So now we can see that this fraction must be bigger because 28 35ths is bigger than 25 35ths. Now remember the inequality sign, that's what this is called, an inequality sign. You can remember which way it goes because Pac-Man wants to eat the bigger fraction. Now, if you don't know what Pac-Man is, that's just an old video game where a yellow head goes around eating stuff. So that's just an old video game. So we write greater than. So this statement is read 4/5 is greater than 5/7. And that's our answer, so we're going to rectangle that. All right, let's try a couple more before you do one on your own. So we're going to multiply both sides of this fraction by 4 to get 4 over 24, and both sides of this fraction by 3 to get 9 over 24. And you can see that 9 over 24 is greater than. Pac-Man wants to eat the bigger one. So we're going to write less than, and that's our answer. Now there's one thing that's kind of important. As long as you know that Pac-Man eats the bigger number, than the bigger value, then that's all you really need to know to figure out which way the inequality sign goes. But when you're reading the inequality sign, it can be kind of confusing. Because I said that 9 over 24 is greater than 4 over 24. The problem with saying that is I'm reading right to left. 9 over 24 is greater than 4 over 24. We don't read right to left in English. We read left to right. So this sign is a less than sign. Because if you read left to right, the other direction, the direction you're supposed to read, it's 1/6 is less than 3/8. So just be aware that when you actually name these signs, this is a greater than sign because reading left to right, it's greater than, and this is a less than sign reading from left to right. But if you read right to left, you're going to get pretty confused. So just be aware of that. But again, as long as you know that Pac-Man eats the bigger number, that's all you really need to know. All right, so let's try one more of these. In this example, we only have to change one of the fractions because if we multiply both sides of 2/5 by 3, we get 6 over 15. And now, without changing the other fraction, we see that they have common denominators, and we can see that we need to put a less than sign because Pac-Man eats the 7 over 15. All right, so why don't you try number 4, and when you come back, we'll do it together. Pause the video. All right, we're back. We're going to multiply both sides of this fraction by 9 to get 9 over 63, and both sides of this fraction by 7 to get 14 over 63. And we're going to put a less than symbol, so if you put a less than symbol, good job. All right, try number 5, and when you come back, we'll do it together. All right, we're back. So in this case, we only have to multiply this fraction by 2, multiply both sides by 2, and we can leave the other fraction. And we can see that we need another less than sign. So if you said less than, good job. Be sure to rectangle your answers. Try number 6, and when you come back, we'll do it together. All right, we're back. Multiply both sides of this fraction by 2, and you get 16 over 18. And multiply both sides of this fraction by 3, and you get 15 over 18. And you can see we need a greater than symbol. So if you got greater than, good job. All right, now in this problem, something different is going to happen because there's actually 2 ways to solve this problem. One way is what we already did. We can make these numbers bigger by multiplying both numbers by some number to get 81 in the denominator. So that's using the fundamental principle of fractions to make these numbers bigger. But we can also take this fraction and we can make it smaller. See, the difference between the previous problems is that in all the previous problems, the numbers were already, or the fractions were already reduced. But in this problem, we have a fraction that's not reduced. So we can try going backwards and reducing this fraction and making the numbers smaller. So let's go ahead and try that. Again, you can just multiply both sides of this fraction by 9 to get 63 over 81. But I'm just going to try reducing this. I'm going to divide both these numbers by 9 to get 8 over 9. And we see that we need a less than sign because Pac-Man eats the 8/9. So again, that's just on these problems, there's 2 ways to do it because one of these fractions is not reduced. So why don't you try number 8, and when you come back, we'll do it together. All right, we're back. So you can multiply both sides of this fraction by 5 to get 35 over 40, but you can also reduce this fraction, dividing by 5 to get 5 over 8. So you can do it 2 ways. I'm just going to do it the reducing way because that's what's different about these problems. All right, so we can see we need a less than symbol. So if you got less than, good job. All right, something new is going to happen on this problem. We have another case where one of the fractions is not completely reduced. So I could multiply both sides of this by 2, or I could divide both sides of this fraction by 2. I'm going to divide, so dividing both sides of this by 2, we get 2/3. And now, what's different about this problem is you can see that these 2 fractions are the same. So we're not going to write greater than, and we're not going to write less than. We're going to write equal to, which is obviously a symbol that you're used to using at this point of the course. All right, so why don't you try number 10. You can either use the fundamental principle of fractions to multiply both these numbers by some common number, or you can divide both sides of this fraction by some common number. So you can do it either way. Pause the video, and when you come back, we'll do it together. All right, we're back. So I'm going to choose to multiply both sides of this fraction by 3 and get 9 over 12 and 9 over 12. So you can see that they are equal. But I also could have divided both sides of this fraction by 3, and I would have got 3/4 is equal to 3/4. If you did it that way, that's fine too. All right, so number 11. Go and attempt number 11, and when you're done, we'll do it together. All right, we're back. So in the previous problem, I multiplied first, so I'm going to reduce in this one. So divide both sides of this fraction by 6, and you get, actually that doesn't work. We got to divide both sides by, divide both sides of this fraction by 4, and we get 6 over 7. So you can see that they're equal to. So if you got equal to, good job. All right. Let me just double check that, make sure that's correct. Looks correct. All right, number 12, something weird is going to happen. I'm going to go and reduce this fraction. I could multiply both sides of this fraction by 5 and get 5 over 20, and then we'd be done. That would probably be the easiest way to do it, but I'm going to reduce because I want to show you that something weird is going to happen on this problem. I'm going to divide both sides of this fraction by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. So now the fractions are completely reduced, but after we reduce them completely, you can see that we don't have a common denominator. 2 and 4 are not common. So now we have to go up. We have to multiply both sides of this fraction by 2. And then that gives us, let me move these up, make them smaller. So we're going to multiply both sides of this fraction by 2 to get 2 over 4. So now we have 1/4 and 2/4, so it's less than. So in that example, when you reduce the fractions completely, we then had to go back up. In the previous problems, when you reduced, we just came up with a denominator that was the same. So that's not always going to happen. In fact, in most cases, that's not going to happen. So again, you just want to use the fundamental principle of fractions. Play around with that principle until you get a common denominator. That's all we're doing here. All right, so number 13. In this case, we have both fractions are not reduced. In the previous examples, only one fraction was not reduced, but in this case, both fractions are not reduced. So the easiest way to do this is to go ahead and just reduce the fractions. Divide both sides of the first fraction by 2 to get 4 over 9, and both sides of the second fraction by 5 to get 3 over 8. And so now the purpose of doing that is we have smaller numbers now to deal with. If we tried to find a common denominator with 18 and 40, that would be really difficult. But now with 9 and 8, it's not too bad. So multiply both sides of this fraction by 8, and we get 32 over 72. Multiply both sides of this fraction by 9, and we get 27 over 72. All right, so we can see that we need a greater than symbol. So that problem required 2 steps. So why don't you try number 14? And it's going to be the same type of problem. So when you come back, we'll do it together. Pause the video. All right, we're back. So we're going to divide both sides of this fraction by 7 to get 3 over 5, and both sides of this fraction by 4 to get 8. Actually, no, both sides of this fraction by 8 to get 4 over 7. And now we're going to multiply both sides of this fraction to get multiply both sides of this fraction by 7 to get 21 over 35, and both sides of this fraction by 5 to get 20 over 35. And you can see we need a greater than symbol. So if you wrote greater than, good job. All right, try number 15, and when you come back, we'll do it together. All right, we're back. We're going to divide both sides of this fraction by 6 to get 8 over 9, and both sides of this fraction by 10 to get 9 over 10. All right, so we're going to multiply both sides of this fraction by 10 to get 80 over 90, and both sides of this fraction by 9 to get 81 over 90. So we can see that we need a less than symbol. Again, Pac-Man eats the bigger one. All right, so that was comparing fractions using inequalities. And again, if you say this inequality, you have to read left to right. 48 over 54 is less than 90 over 100. You must read left to right, not right to left. Don't confuse yourself if you state that inequality out loud. It's a less than symbol. Whereas this would be a greater than symbol. Why? Because you're reading left to right. That's how you read in the English language. All right. So now we're going to do the same exact thing, except we're going to do it with decimals. One method for solving these problems that we just did is we could all just convert them to decimals, but that would have been more difficult in most cases. But in this case, we have the decimals already written, so we're going to figure out how to tell which decimal is bigger. So let's say that you have something like 48.962, and you have 7.999. The first thing you do to figure out which decimal is bigger is you look at the number farthest to the left in each of these numbers, so that would be 4 here, and that would be 7 here. And then you ask yourself, which place are these numbers in, the yellow? The 4 is in the tens place. That's in the tens place. And the 7 is in the ones place. So this place is a bigger place because tens are bigger than ones. So if a number is farther to the left in its position, that means it's a bigger number. This is 40, but this is only 7 ones. So we know that this number is bigger. All right? So that's the first thing that you do, is figure out what, obviously 48 is bigger than 7, so that's pretty easy. The second thing that you have to do is, actually we're done with that problem, but let's say that 4 were not there. So now you're analyzing 8 and 7 to figure out which is bigger. Again, you look to the number farthest to the left. So now we can see that both of these yellow numbers are in the same place. So because they're in the same place, how do we know which one is bigger? Well, obviously the 8 is bigger, which means that this number would be bigger in that case. So it turns out that this number was bigger in both cases. But if this number were a 6, obviously this number would be bigger. So that's how you tell. So we're going to go through those steps. If you didn't understand that, that's okay. We're going to go through these steps and you'll get this as we go along. So we look at the numbers farthest to the left, and it turns out that both those numbers are in the same place, the 10th place. And I wrote the place names up here. So they're both in the 10th place, so we just have to figure out which number is bigger, and obviously the 4 is bigger, so Pac-Man eats the bigger number, and we have to write a less than symbol. It's called less than because we're reading from left to right. Left to right. Now you're probably thinking, well, wait a second, this is 35. How can 35 be smaller than 4? Well, this is 35 100ths, and this is 4 tenths. So it's more complicated than that. If you add a 0 here, this becomes 40 100ths, whereas this is only 35 100ths. So again, decimals are more complicated than that, so you got to get the hang of this. All right, number 17. Figure out which number is farthest to the left in each of these. And we've got these ones that are farthest to the left. But the important thing to understand is that this 1 is in the 1000th place, and this 1 is in the 100th place. So because the 1 in the 100th place is farther to the left in terms of its place name, that means that this number must be bigger. So even though the numbers are the same, this number is farther to the left. This number is 2 places over, and this number is 1 place over, if you want to count that in terms of places, I guess. So this number must be bigger. Pac-Man eats that, so we need another less than symbol. So again, if you're having trouble with this, don't worry. We're gonna do more of these problems. So we look to the number farthest to the left, and we get 3. And both those 3s are in the tens place, so they're both in the tens place, and they're both 3s. So what that means is that doesn't tell us which number is bigger. We then have to go to the number next to that number, and we have 6, and both those 6s are the same, so we still don't know which value is bigger. So then we go to the next number over, and we have a 0 here, and we have an 8 here. So because we have an 8 in the 10th place over here in the red, and we only have a 0 on the other number in the red, that means this number must be bigger. So we write another less than symbol. And this is a special case where I'm trying to trick you by writing this 0 here. But remember that ending zeros, they can just disappear when they're to the right of the decimal, because this is 5 tenths and this is 50 100ths. But 5 tenths is the same thing as 50 100ths, because 50 100ths, if you divide both sides of this fraction by by 10, you just get 5/10. So both these expressions, these decimals, are equal. So don't get fooled by decimals that look equal, but they're not really equal. That's a rookie mistake for junior mathematicians. All right, so it's time for you to try one. So try number 20. When you come back, we'll do it together. All right, we're back. So look to the number farthest to the left. They're both in the ones place, and they're both 1, so that doesn't help us. Look to the number to the right, and we have 3's that are both in the 10th place, and they're both 3's, so that doesn't help us. The next number is 0, so that doesn't help us. And then the last number, oh, here there's nothing, which means it's the same as 0, but over here we have a 1. So Pac-Man wants to eat the number on the right. So it's another less than symbol. All right. So if you got less than, good job for number 20. All right, number 21. Attempt that problem, and when you're done, we'll do it together. All right, we're back. So the number farthest to the left is 9 here, and the number farthest to the left is 9. So what place are those numbers in? They're both in the 10th place. And the one with the 9 is going to be bigger. So if you wrote a greater than sign, good job. All right, try number 22, and when you come back, we'll do it together. All right, we're back. So remember, these zeros can just disappear, which means that 3.9 is equal to 3.9. Same situation here, so try number 23, and when you're done, we'll do it together. All right, we're back. So these zeros can disappear. If you're wondering where the decimal is in this number, the decimal is here, because remember, when you don't see the decimal, because we're dealing with a whole number, the decimal is always directly to the right of the number in the ones place, which is 0 in this case. So the decimal will be right there. So you get rid of these zeros because they're ending zeros to the right of the decimal, and you just end up with 10 equals 10. So if you got equal to, good job. All right, so we figured out how to determine which fractions are bigger. We determined how to figure out which decimals are bigger. And now we're going to continue with those concepts. For number 24, we're going to arrange the values from least to greatest. So we have to take all these values and determine which one's the smallest and which one's the biggest, and so on and so forth. So the way that we do this is we can't look at these terms and figure out which one is bigger and which one is smaller, because it's difficult. I mean, we can tell that this one is bigger than this one, but other than that, it's kind of difficult to tell. So what we have to do is we have to change all these terms to decimals, and then we can easily see, using the principles we just talked about, the problems we just talked about, or we can change all these to fractions and then get a common denominator, as we did in the previous problems over here. So it just depends on which method is easier. Now in this case, we only have one decimal, so if we convert this to a fraction, that's not going to be that much work, and then we just have to figure out what the common denominator is. So in this case, it's going to be a lot easier to change these all to fractions. And in fact, if you try to change these numbers, well, I guess that doesn't really matter, but yeah, in this case, it's just going to be best to change these all to fractions. So we already have a fraction here. The 6 is in the 10th place, so that's going to be 6 over 10. And there you go. Now we have fractions. The problem is we can't really compare the fractions very easily because they don't have common denominators. So we're going to find a common denominator. We're going to multiply both sides of this fraction by 15 to get 15 over 30, and that's not one of your multiplication facts, so I'm sorry about that. Multiply both sides of this fraction by 3, and we get 18 over 30. Multiply both sides of this fraction by 10, and we get 10 over 30. And same thing with this fraction. Multiply both sides by 10, and we get 20 over 30. So now we can see which fraction is the smallest. Obviously, it would be 10 over 30, which is 1/3. So I'm going to write 1/3. Notice I'm writing it in the original form. And so we can cross that one out. We're done with that one. And the next fraction, the next biggest, is going to be 15 over 30, which is 1/2. And make sure to write your commas. So we can cross that one out. We're done with that one. It really helps to cross these out. In fact, let's see here, I shouldn't be crossing these out with, I can do that with the highlighter instead. All right, so the next one is going to be 18 over 30, which is 0.6. And instead of 18 over 30, I'm going to write 0.6 because that's the original form. And then the last one is going to be 2/3 because 2/3 is the 20 over 30. So that is the answer for this particular problem. And I know what you're thinking. You're thinking that was a lot of work. Well, these are quite a bit of work, but this is really good practice for you to remember how to convert from fractions to decimals and decimals to fractions. All right, so let's try 25. 25 is going to be a problem where we're going to, it's going to be easier to change all these to decimals. Yeah, I think it would be easier to change to decimals. Actually, it would be about the same difficulty for both methods, but just to demonstrate how to change to decimals, that's the other way to do it. We change to fractions on this one, and then we got a common denominator. So for this one, we'll try the other method. We'll switch to we'll change all these to decimals. And the reason I think it would be a little bit easier is because 0.89 would be 89/100ths. So we'd have to change all the denominators so they would be 100. So that wouldn't be super easy. It's not terribly hard, but it wouldn't be that easy. So we're going to go ahead and convert these to decimals. So the method that works in every case is to take the numerator and divide by the denominator. So 4 divided by 5, and we're going to use the long division algorithm if you remember. Changing fractions to decimals, 5 goes into 40 8 times. 8 times 5 is 40. Remainder is 0. Bring up the decimal. So that becomes 0.8. So we could do the same thing with this fraction. Again, this method of dividing the numerator by the denominator always works. If you're just looking for one method and you want to memorize that one method, then that's the method you want to use to change a fraction to a decimal. You take the numerator and divide by the denominator using the long division algorithm. But I can see that we have a power of 10 in the denominator here, so that would just be a waste of time. I know that this is just defined as 0.7 because 7 is in the 10th place. And this is 7 over 10. So again, you can use this method every time, but if you want a shortcut, just realize that that's the definition of a decimal. All right, so now we changed all the values to decimals. So now we have to figure out which one is smallest. So we have to use the methods that we went over previously. So look at all the numbers farthest to the left. And they all just happen to be in the 10th place. So we have to figure out which number is smallest, and obviously 7 is smallest. So 7/10 is going to be the smallest number. So I'll mark that out with red. We're done with that one. Actually, I'm not going to be able to do that. All right, and the next number over, let's see here. So now we have two numbers with 8. So we have to go to the next number over. So the next number over here is 0. There's nothing there. And the next number here is 9. So the 0.8, which is 4/5, that has to be the next biggest number. So I'm going to write 4/5 there. And so I'm going to cross these out with that tool there. All right, and then we just have to figure out which one is bigger here, but we already know because the yellow numbers, 0.89 has to be smaller. And that should be our final answer. So again, you can change them all to fractions, or you can change them all to decimals. But in some cases, it's not even going to be possible to change all these expressions to fractions. For example, if you have a repeating decimal, we haven't learned how to change a repeating decimal to a fraction. So when you see a repeating decimal in these problems where you have to order or arrange the values from least to greatest, then that tells you that you have to change all these to decimals. So again, if you're having trouble in the homework with this stuff and you're not sure, just try the different methods and whatever works. That's what you got to use, obviously. All right, now let's try. Why don't you try number 26? And in this problem, I'm going to tell you right now that if you try to change them to fractions, this is going to be 2009 over 10,000, because the number farthest to the right is in the 10,000ths place. So it's going to be that, and obviously we don't want to deal with that. So in this problem, you're going to want to change all these numbers to decimals. So go ahead and do that, and when you come back, we'll do it together. All right, we're back. So 1 divided by 4, 4 goes into 10 2 times, remainder 2, bring down a 0. 4 goes into 25 times, 20, remainder 0, bring up the decimal, and 1/4 becomes 0.25. Now I know I'm doing that quickly. I know I'm doing that fast, but this is all review. So you can always look back in the classes, or the class where we learned how to convert fractions to decimals if you're having trouble with that. So we're just going to rewrite this decimal. And now we have to do 3 over 8. So you take the numerator, divide by the denominator. 8 doesn't go into 3, so we have to add a 0. 3 times 24, remainder 6, bring down a 0. 8 goes into 60. I'm running out of room here. 8 goes into 60 7 times, which multiplies to 56. Remainder 0, bring down another 0. 8 goes into 40. Whoops. 8 goes into 45 times. 8 times 5 is 40. Remainder 0. Decimal goes straight up. So we have 0.375. And so we did it. We converted all these to decimals. So if you didn't do it correctly, hopefully you saw what you did wrong. So now we just have to figure out which is bigger. So we look to the numbers farthest to the right, or excuse me, farthest to the left. And they're all 2s, except one is a 3. So we can write the 3/8. That's got to be the biggest number. So we can go ahead and write that over here, 3/8, and we can cross that one out because we know we don't have to deal with that one anymore. So because these other numbers, these other yellow numbers are 2s, we have to go one number to the right, and we have a blue 5, a blue 4, and a blue 0. So the 0 is the smallest number, so that's going to be the smallest, 0.2009. That goes over here. And I know that this method with all these colors, it seems kind of complicated, but it's really not. You're going to get the hang of this as you do more and more of these problems. It's really quite simple. All right, so now we can cross that one out, and now we're looking at these two over here. So obviously the 4 is smaller, so it's 0.24. And then the 0.25 is the next biggest number, but we're going to write that as 1/4. That's the original form. So if you got that order, good job. So that was a case where we had to change all the numbers to decimals. So 27 is a problem where it's going to be easiest to change all of these to fractions. So the 2, let me just get you started here, because these are somewhat different because we have whole numbers here. So these are we have mixed numbers, and these are going to turn into mixed numbers too. So let me just get you started, and then you can do the rest of it. So for this one for example, the 6 is in the 10th place, so that's just going to become 2 and 6/10. Very easy. And if you want to reduce it, it would be 2 3/5. So these problems are pretty much the same thing. You just let the two whole numbers just hang out in front there. So this is a problem where we're going to change all of these to fractions. That's the easiest way to do it. You can change them all to decimals also, but the easiest way in this particular problem is to change them all to fractions. So why don't you attempt 27, and when you come back, we'll do it together. All right, we're back. So we're just going to rewrite that one, and then that will become 2 6/10. And then the 7 is in the 10th place also, so 2 7/10. So now we've changed everything to fractions. And you can see pretty clearly that, the next step is to get a common denominator. You can see pretty clearly that 10 is going to be the common denominator, so we're going to multiply both sides of this fraction by 5, and we get 5 over 10. And this is all review, by the way. And multiply both sides of this fraction by 2, and we get 4/10. So you probably haven't done that in a while, so I probably should have done this one with you, but anyway, we got it now. So now we can see that the 2 4/10 is going to be the smallest value, and that is 2 2/5. So we write 2 2/5 first. If we can cross that one out, we got that one. And then 2 5/10 is the next biggest. That's 2 1/2. So we can cross that one out. We got that one. And then 2 6/10, which is 2.6. That's the next biggest one. And then the last one, 2.7. So if you got that order, good job. Again, we took a mixed number and we changed the form of the fraction. We haven't done that in a while, but hopefully you get the point there. All right, on to number 28. Let's see. Now this would be 901 over 1,000. So unless you want to somehow get these denominators to become 1,000, it's not going to be easy to change these to fraction form. So instead of changing these to fraction form, we want to change these to decimals. So go ahead and try 28. Use the long division algorithm to change these to decimals, and when you come back, we'll do it together. All right, we're back. I'm going to shrink this because I'm running out of room here. All right, so 5 divided by 6. And you can see it's just going to be a repeating decimal. I just keep getting 3, 3, 3, 3, 3, 3, and bring the decimal straight up. So 5, 6 is 0.83 bar. Bar means it just keeps going on forever. So now 11 divided by 12. 12 goes into 11, doesn't go in at all, so we have to add a decimal and a 0. 12 goes into 110 9 times, I believe, and notice I put the 9. Sorry, it's getting kind of cramped here. Notice I put the 9. I put the 9 above the 0. It has to be above the 0. 9 times 2 is 18, carry the 1. 9 times 1 is 1, or excuse me, 9 times 1 is 9, plus 9 is 10. So you could do that down here, 12 times 9 with the multiplication algorithm. But I'm doing it the easy way, or the faster way. It might not be easier, but 9 times 2 is 18, carry the 1. And we went over that method. So if you're wondering how I'm doing this quickly, that's how we're getting it done. So now 110 minus 108, you could borrow, because we can't do 0 minus 8, so you could borrow and then give to the 0 and all that, but it's really not necessary because 110 minus 108, that's so easy to do in your head. All right, so it's 2. Now bring down a 0. 12 into 20 goes 1 time. 1 times 12. Subtract. Bring down a 0. 12 goes into 80 6 times, I believe. And remainder is 0. And you can see that it's just going to keep going on and on and on. So we have, bring the decimal straight up, we have 0.916 bar. 0.916 bar. All right, so we did it. We changed all of them to decimals. So now comes the easy part. Because they're all in decimal form, which are fractions with powers of 10 in their denominators, or abbreviations of fractions with powers of 10 in the denominators, we can really easily figure out which one is bigger. We have an 8, a 9, a 9, and a 9. They're all in the 10th place. So obviously the one with 8 is going to be the smallest value. So we write 5, 6 first. So we're done with that one. And then we have 9s in all the other numbers, so we have to go to the next number over. We have a 1, and a 0. So the one with the 0 is going to be the next biggest number. And we can cross that out. And now we have to go to the next number over. which is going to be a, let me get a different color here. It's going to be a 6, and over here there's nothing. So the one with nothing, that's going to be the smaller number. And then, so we cross that one out. And the next one is going to be 11 over 12. This is the biggest number. All right, so that looks correct. So if you got that answer, good job. Just double checking that. Looks right. Okay, so number 29. Again, this is 222 over 1,000. So we don't want to get it's going to be hard to get a common denominator of 1,000 with these two numbers here. 2 ninths and 1/8. So it's better to just convert all these to decimals. So go ahead and convert all these to decimals, see which is bigger and which is smaller, and when you come back, we'll do it together. All right, we're back. So 2 divided by 9, we use the long division algorithm to convert it to a decimal. 9 goes into 20 2 times, remainder 2. Bring down a 0. 9 goes into 20 2 times again. And you can see it's just going to keep going on and on and on. Bring the decimal straight up. So it's a repeating decimal. So that becomes 0.2 bar. Now we can just rewrite this one. And 1/8. Let me move this up and shrink it a little bit. We're going to do 1 divided by 8. 8 doesn't go into 1. Add a 0. And a decimal goes in 1 time. Remainder 2. Bring down a 0. 8 goes into 20 2 times. 8 times 2 is 16. Remainder 4. Bring down a 0. 8 goes into 40 5 times. Remainder 0. Bring the decimal straight up. So you have 0.125. All right. So now they're all decimals. So number farthest to the left is 2, 2, 1, 3, and they're all in the same place. They're all in the 10th place. And the reason they're all in the 10th place, and they seem to be all in the same place for all the last 4 or 5 problems we've done, is because we're trying to make it so that it's not obvious which one is bigger. But in these problems, well, that was the same situation for these problems. But if you have a situation where you have 0.288, for example, and you have another number that's 0.000999, obviously this number is bigger because we have a 2 in the 10th place, whereas here we have a 0. So just be aware that that makes it even easier. But with our problems, we're making it difficult because these numbers are really close together. So all the yellow numbers are, actually we have one yellow number that's a 1. So the 1/8 is going to be the smallest number. Then we have a 3 over here, which means that's going to be our biggest number. Let me cross that out. Our biggest number is 0.3 bar. And cross that out. And now, on the next number over here, we have 2, because remember, it's repeating. It's 2, 2, 2, 2. We have a 2 here. So those blue numbers don't tell us which number is bigger. We have another number over here that's 2 again, because again, it's repeating decimal. It goes on forever, just 2, 2, 2. Here we have a 2. So it doesn't tell us the answer again. So now we have to go over again, and we have another 2 here, because again, it's just 2 to infinity. But over here, we have no more 2's. So that means that this number must be the smaller number, so that comes next. I just want you to know you can do this pretty quickly in your head. You don't have to, do it as slow as I'm doing it. I'm just trying to explain how to do it, so it's taking longer to explain it. And that goes for pretty much everything in this class. Just because it takes me long to explain it doesn't mean it's going to take you long to do it. As long as you know how to do it, you can do it very, very quickly. So if you got that order, good job. A lot of work in these problems. So these problems are keeping us busy. All right, so for the next problem, again, it's not going to be easy to change all these to fractions, so we're not going to use that method. Most of the problems that we've done here are problems that require us to change to a decimal, but we did do a couple problems where we changed to fractions and found a common denominator. That's another way we can determine which value is bigger, or the order of the numbers. So we're going to change all these to decimals. Why don't you go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. So we can just rewrite this one. And then 7 over 8, we have to do that. I don't really have much room. I'm going to go ahead and erase this. I hate to erase the work there, but we just don't have any more room. All right, so 7 divided by 8. Goes in 8 times. 8 into 60 goes 7 times, so on and so forth. And bring the decimal straight up, so 7/8 is 0.875. Now we have to do 8/9, so I don't have any room here, so I'm going to erase that. 8/9, so 8 divided by 9. 9 goes in 8 times, which is 72. Goes in 8 times again, and as you can see, it's just going to be a repeating decimal. It just keeps going in. So it's going to be 0.8 bar. Now we'll just rewrite this one. So we did it. We changed all of them to decimals. So now look at the number farthest to the left, and it's we get a 7, an 8, an 8, and an 8. So obviously the 7, the 0.79 is the smallest number, and we can cross that one out. Then we have to go to the next number, so we have a 9, or excuse me, we have a 7, and we have an 8, because these keep on going forever, 8, 8, 8, 8, and we have another 7. So we have, obviously the 8, 8, 8, 8 problem is the biggest, so we can write that over there and cross that out. And we have to go on here with another color. So we have a 5, and then we have a 6. So the one with the 5 is going to be the smaller number, and that is 7/8. So 7/8. And then the next biggest number is 0.876. So if you got that order, good job. All right, number 31. 31 is a problem where we're going to have mixed numbers. So we did one of those problems previously. But this is a problem where, because we have repeating decimals, we cannot change these repeating decimals to fractions. Now, it is possible to change a repeating decimal to a fraction, but it requires some things that we haven't learned in this class, some concepts that are a bit advanced for this level. So the only way to do this problem is to change all of these to decimals. Now, I repeat, if you see one of these types of problems where you have to arrange the terms from least to greatest, and there's repeating decimals, you cannot change these to fractions. You have to change them to decimals. You have no other choice. All right, so go ahead and attempt this problem. Change those values to decimals and order from least to greatest. And when you come back, we'll do it together. All right, we're back. So 2 over 5 is going to be 0.4. So we just add that 0.4 to the 8. This part is the 0.4 part. Then we can just rewrite that and rewrite that. And 1/2, we'll do that over here. 1 divided by 2 can't go into 1. Have to add a 0. Bring the decimal up, and we have 0.5. So we just add that to the 8. This part is the 0.5 part. And we're ready to go. So now the number farthest to the left is 8, 8, 8, and 8. So that didn't help us figure out which one is bigger. Now we go to the next number, 4, 4, 4, and 5. Well, we did figure out which number is biggest. The 8.5 must be biggest. So 8 1/2 is the biggest, and we can cross that one out. Now we look to the number further to, we have 0 here. We have a 4 here, because again, these are repeating decimals that go on forever. And we have a 3 here. So the one with 0 is going to be the smallest. That's 8.4, but we're going to write it as 8 2/5. And then the one with the 3 is the next smallest. So that's 8.43 bar. And the one with the 4, remember this is, just goes on forever, 4, 4, 4, 4, that's the next biggest. And so that is the order. And I can move this over a little bit. So if you got that order, you did it correctly. Good job. I have to move that one over a little bit. I missed that. All right. 8.4, let me just double check that. That looks right. All right, so we're done with those problems. Again, we figured out which fraction is bigger. We figured out which decimal is bigger. Then we learned how to order or arrange fractions and decimals in order from least to greatest. So we're converting back and forth between decimals and fractions. We're figuring out which is bigger, so on and so forth. So now we're going to use some of this knowledge in the next problems. In the next problems, all we're doing is we're just adding a bunch of expressions. But the problem is we have decimals and fractions. We can't add a decimal with a fraction. We have to either convert all of these to decimals, or we have to convert all of these to fractions and get a common denominator. So again, this is just another situation where you have decimals and fractions, and we have to deal with them. So we have learned how to add mixed numbers with whole numbers, and mixed numbers with fractions and whole numbers, and so on and so forth. We know how to combine those based on previous classes. You may not remember right now, but we've already done that. What we have not done is we have not combined a decimal with these other three, fractions and mixed numbers and whole numbers. So that's the point of this part of the class. So what you do is pretty much the same thing we did in the previous problems. You change, again, you change all these to decimals, or you change all of them to fractions, and then we can add them together. So in this case, either way works, but the way that's going to be easiest in this case is actually to change all these to fractions. So we look at this decimal here, and this 3 is in the 10th place, so it's just going to be 2 3/10. And I think I'm going to get a smaller pen because I feel like this might be this might go on for a while here. So 2 3/10, and we did it. We changed all of them to fractions. So now we just have to get a common denominator. So the common denominator is obviously going to be 10 if you know your multiplication facts. So we're just going to keep this fraction, and then we're going to multiply both sides of this fraction by 2 to get 8/10. And both sides of this fraction by 5 to get 5/10. And now we can just add those. Well, first we add the whole numbers, the 2 and the 3. So 2 and 2, oh, excuse me. There's 2, there's 3, and there's also 1. I almost missed that 1. So 2 plus 1 is 3, plus 3 is 6. So we write the 6, and then we just have to add the fractions. 3/10 plus 8/10 plus 5/10. So let's see, what do we get there? 3 plus 8 is 11, plus 5 is 16. So we get 16/10. But we have a problem here. We have two problems. One problem is that this is not reduced. In other words, we can use the fundamental principle of fractions to get smaller numbers. But another problem, a bigger problem, is that this is an improper fraction. So what we have to do is we have to interpret this mixed number and separate it. What this means is 6 plus 16/10. I don't know if you remember that, but that's what a mixed number is. When you put a whole number next to a fraction, it means that you're just adding those up. But we write this as a more compact form. So I have to separate these two. Now I have to convert this improper fraction to a mixed number. Now, it's been a long time since we've done this. It's been weeks and weeks and weeks. So if you don't remember how to do this, that's okay. We're going to remember how to do it right now. And if you want to go back and practice more, you can go to the part of the course or the class where we learn how to convert an improper fraction to a mixed number. That's the mixed number part of the course. So here's how you do it. You figure out how many times 10 goes into 16. Well, obviously it goes one time. What's left over? 6 is left over because 16 minus 10 is 6. And then the denominator is just going to be the same thing. It's just going to be the same denominator. So again, that's just review. So you figured out how many times the denominator goes into the numerator. It goes in one time. You put your 1 there. And 10 times 1 is 10. But there is a remainder of 6. So 16 minus 10 is 6. That goes in the numerator. And you just rewrite the denominator. Okay, so now we just have one more problem. And that is that this fraction is not reduced. So we can divide both sides by 2 to get 3/5. And finally, I'm going to make this a little smaller. Finally, we can add everything together. 6 plus 1 3/5. You just add the whole numbers to get 7 3/5. So yes, I know that was a lot of work. These problems are quite a bit of work, but these are really, really good practice for converting between fractions and decimals and using all the algorithms that we learned previously. All right. So again, don't get all worried about this if you're not remembering some of this stuff. You can always just go back to the previous classes and review this stuff. Now, I know that you don't want to go back to the previous classes and review this stuff. That's okay. That's natural, but you're just going to have to do it because it's only going to be a couple more classes before we actually take the final exam, so you're going to have to do it one way or the other. All right, so number 33. Let's see. For number 33, I think it would be probably a little bit easier to change these to fractions rather than to change them to decimals. So this will be a good opportunity for you to get practice changing to fractions. So why don't you try 33, change this decimal to a fraction, and then add them all up. And when you come back, we'll do it together. All right, we're back. So we're going to rewrite the fraction there. And that's in the one's in the 10th place, so we just write 1 over 10, very easy. All right, so now we just have to get a common denominator, which is obviously going to be 10. Actually, no, it's not going to be 10. It's going to be 20. So multiply both sides of this fraction by 5, and you get 5 over 20. Multiply both sides of this fraction by 2, and you get 2 over 20. Multiply both sides of this fraction by 2, and you get 4 over, multiply both sides by 4, and you get 8 over 20. So now we have common denominators. So now we just add the whole numbers first. So 3 plus 9 is 12. So we write our 12 there. And we add the fractions. So 5 20ths plus 2 20ths is 7 20ths. And then 7 20ths plus 8 20ths is 15 20ths. So in the previous situation, we had a fraction over here where we had two problems. One problem is it wasn't reduced, and the other problem is it was an improper fraction. Well, in this case, we only have one problem because this fraction is already it's a proper fraction. It's not improper, so that we don't have to deal with that situation. But it's not reduced. So we can divide both these numbers by 5, and we end up with our final answer is 12 and 3/4. So if you got 12 and 3/4, good job. Now I know I'm going kind of fast through these problems, but I just want to. I don't want to go over time in this class. So now let's look at the next problem here. Let's see what would be easier, to change to decimals or to change to fractions. Let's see. I think this is going to be easier to change to fractions again. In the next problem that we're going to do, we'll change it to decimals, and you can just see how that works also. We'll change all the terms to decimals. So try number 34, and when you come back, we'll do it together. All right, we're back. So the first two terms are already in fraction form, the 6th and the 10th place. So it'll be 5 and 6/10. And so we've changed everything to fractions. Now we just have to get a common denominator. I just realized the common denominator, oh, actually no, I guess it's going to be fine. The common denominator is going to be 40. So multiply both sides of this fraction by 10, and you get 10 over 40. Multiply both sides of this fraction by 4, and you get 24 over 40. Multiply both sides of this fraction by 5, and you get 35 over 40. Okay, so now we just add the whole numbers, the 10, the 2, and the 5, and we get 17. And then add the fractions, 10 40ths, 24 40ths, and 35 40ths. You can do that. You can do that over here if you want, but I'm just going to do it in my head. Well, now that I have it written down, I might as well just do it here. So 69. We got 69 there. So 69 over 40, if we add all those up. 10 40ths plus 24 40ths plus 35 40ths is 69 40ths. So we have one big problem here, and that is that this is an improper fraction. So we have to put it in a separate, or to separate these, just based on the definition of mixed numbers. And then we have to change this to a a mixed number. So 40 goes into 69 one time. 40 times 1 is 40, and then the remainder, 69 minus 40, is 29. And the denominator is just going to be the same. All right, so now we just add these two together. So 17 and 1 are whole numbers. We just add those up, and we get 18. And then the 29 over 40, whoops, that doesn't look like a 29. 29 over 40 just hangs out next to it. So if you got 18 and 29 40ths, good job. These problems are a big challenge. So if you're doing these, I'm proud of you. All right, on to number 35. So for 35, in this case, it's going to be actually a little bit easier to change all these to decimals. But first of all, this is a word problem, so we have to figure out what they're asking. So it says find the perimeter of the triangle below. So what is perimeter? Well, perimeter is just the distance all around. So this length plus this length plus this length. So we have all the lengths given to us. Whoops. So all we have to do is just add all these lengths. So 1 1/5 plus 0.59 plus 0.7. But like I said, it's easier to change all these to decimals rather than change them all to fractions. So we only have one fraction form here. So we're going to have to change 1/5 to a decimals. So take the numerator, divide by the denominator. 5 goes into 10 2 times. Remainder 0, so bring up the decimal, and that becomes, so 1/5 becomes 0.2, which means we can just tack it on to the 1. All right, so 1 and 1/5 becomes 1.2. And I'll just rewrite the other numbers. So now we have to add decimals, but adding decimals is really easy because we already know how to do that. We learned how to add decimals in the operations with decimals class. So the key is to line up the decimals. If you don't line the decimals up, you're going to get the wrong answer. So now, see how I lined up all the decimals? When you're adding and subtracting decimals, you have to line them all up. If you don't line them all up, then you're guaranteed to get the wrong answer. I would suggest putting zeros as placeholders so we can make sure everything's lined up. Now we add all these numbers to get 9. We add all these numbers to get 14. Carry the 1. Add all these numbers to get 2. So we have 2.49. Now if I rectangle that answer, I'm going to get 1 point taken off. Why? Because we need our units. We need inches. So IN. So the perimeter is 2.49 inches. So that was an example where we changed everything to decimal form. Here's another example where it's easier to change everything to decimal form. So just change this fraction to a decimal and tack it on to the 5, connect it to the 5, and use your algorithm for adding decimals. And when you come back, we'll do it together. Pause the video. All right, we're back. So we're going to change everything to a decimal form. The 5 is just going to be 0.4. I think we've done that one quite a few times already, so I don't want to do it again. It just become 0.4. So now we use our algorithm for adding decimals. Most important thing is to line up the decimals. But here's a situation. We have to put the 7. Where do we put the 7? Well, there is no decimal on the 7. Where is it? Well, it's there. It's just invisible because 7 is a whole number. Whenever you have a whole number and you have no fraction part of it, there's not going to be any decimal. But the decimal is there. It's always directly to the right of the number in the ones place, and 7 is in the ones place, so the decimal goes right there. So that means the 7 needs to go right there. And 5.4 and 3.2, make sure everything's lined up. We can put zeros for placeholders. Add up these numbers. Let me see if that's lined up properly. Just double check that. Add up all these numbers and we get 14. Carry the 1. Add up all these numbers and we get 17. Whoops. Move that over a little bit. And then we just have to figure out where to put the decimal. So the decimal always goes straight down when you're adding and subtracting decimals. When you're multiplying or dividing decimals, that's not the case. But with adding and subtracting, it just goes straight down. So the final answer is 17.4. So if you got 17.4, good job. You're doing good. All right. On to the next problem. Now, here's a problem where we cannot change the numbers to decimals. We can't do it. Well, we can do it, but the problem is we're going to get a repeating decimal. This is a repeating decimal, and this fraction is a repeating decimal. So we haven't learned how to add repeating decimals in the decimal form. So we can't do it. So we have to change all these to fractions and then add them up. So we did that once before. We did that in the previous problems up here. So now we're back to changing to fractions. And if you're doing your homework and you come across some repeating decimal and you don't know how to add it up, or you have a repeating decimal and you're trying to convert it to a fraction, just realize that we can't do that. We haven't learned that yet. So if you have a repeating decimal, there's two situations. If you have a repeating decimal and you're trying to change it to a fraction, we can't do that. So just convert everything to decimals instead. But if you also have a situation where we have a fraction that becomes a repeating decimal and you're trying to add it to something else, we can't do that either. We can't take a repeating decimal and add it to another decimal. We haven't learned how to do that. So it's not that you can't do it, it's just that we haven't learned how to do it. That's a more advanced concept and for courses after this course. To be honest with you, that's not really even taught in the curriculum generally. But just be aware that if you have a repeating decimal and you don't know what to do with it, then just keep the fraction form or just keep it as a decimal, depending on the context. All right, so we're going to keep these as fractions, as we said. The 4 is in the 10th place, so that becomes 4/10. And now we have fractions. So now we just have to figure out what the lowest common denominator is. And we could reduce this, but it wouldn't be really necessary at this point. So I'm just leaving that as 4/10. All right, so the common denominator is going to be 30. So multiply both sides of this fraction by 10, and you get 2 and 10/30ths. Multiply both sides of this fraction by 3, and you get 12/30ths. And multiply both sides of this fraction by 5, and you get 25/30ths. I'm going to move this down a little bit. It's getting too close there. All right. Just double checking that. Make sure everything's good. Make sure we didn't make any stupid mistakes. All right. Now we just add the whole numbers, the 2, the 7, and the 6. So that would be 15. And now we add the fractions. I'm going to do that in my head. That's 47/30ths. And now we have a problem. This is an improper fraction. So we're going to have to break this up using the definition of mixed numbers. Then we're going to have to convert the 47/30 to a mixed number because it's an improper fraction. 30 goes into 47 one time. 47 minus 30, or excuse me, 30 times 1 is 30. And then 47 minus 30, the remainder is 17. And just keep the denominator. So now we're going to add these together. The 15 and the 1 just add together. They're both whole numbers. And we just put the fraction right next to that number. All right. So good job on that one if you got the right answer. So that's adding decimals and fractions, but now we're going to multiply. We're going to multiply, and then we're going to subtract, and then we're also going to divide. So it turns out this is the most important thing for you to understand when you're multiplying these values. You have to convert everything to fractions. You don't have to, but it's just going to make it a lot easier. In the previous problems, sometimes you convert everything to decimals, sometimes you convert everything to fractions. Depends on which is easier. But in this case, it's going to be easier to, it's always going to be easier to convert everything to fractions. And whenever you have a mixed number, you're going to convert that to an improper fraction. Because we learned when we figured out how to multiply mixed numbers in the previous class that you cannot multiply or divide mixed numbers. You always have to convert them to improper fractions. So let's go ahead and do that. 2/3 that's already a fraction. 5.5, that's in the 10th place, so that would just be 5/10. And then now we have to convert a mixed number to an improper fraction. So now we're going backwards. We had problems where we had to convert from an improper fraction to a mixed number. But now we're going the opposite direction. So again, this is just review, but we haven't done it in a while. So you multiply these two numbers and then add it to that number. And that's your numerator. 6 times 1 is 6, plus 1 is 7. Then you rewrite the denominator. So that's it. 1 and 1/6 is the same thing as 7/6. Then the 4, that's a whole number. So when you multiply fractions by a whole number, you can just consider that whole number to be over 1. Any whole number can be considered to be over 1. So now we are ready to go. We're going to go ahead and multiply, but before we do that, I'm going to reduce this fraction because that fraction is not reduced. It's going to make it easier for us if we can just reduce that one. All right, so now we're going to go ahead and multiply. So when you multiply fractions, if you recall, you just multiply the numerators, and that becomes the numerator of your product. and you multiply the denominators, and that becomes the denominator of your product. So the numerator is going to be 2 times 1 times 7 times 4. And you get the point. So now we're going to go to the right because we're running out of room here. And I'm going to continue to factor. There's one thing in here that has not been completely factored. Now you're probably wondering, well, wait a second, why did you write it like that? Why don't you just multiply all these? Just do 2 times 7 is 14, 14 times 4 is whatever that is, 56. And then 3 times 2 is 6 times 6 is 36. Why don't you just do it like that? Why are you keeping it in this form? Well, the reason I'm keeping it in this form is that 56 over 36, which is the answer that we're going to get, that's not reduced. Also, it's an improper fraction, but we'll deal with that later. But it's not reduced. So we're going to have to then divide to reduce it. But the problem is we already have the factors here, so that's like going backwards. So I'm keeping it in factored form on purpose so that I don't have to, go backwards and reduce, because we already have the reduced form or the factored form. So what that means is we're going to go ahead and factor everything completely. I'm going to change the 6 to 2 times 3. And oops, I forgot, the 4 is also not in factored form. So instead of writing the 4 up there, I'm going to write 2 times 2. So now we have what's called the prime factorization. It's been a while since we've done prime factorization, but maybe you remember that. So the reason I did that is because now I can see that there's a 2 on the top and a 2 on the bottom, and they cancel out. And there's a 2 on the top here and a 2 on the top there, so they cancel out. And so now I think that's about it. So now we can multiply across. 1 times 7 times 2 is 14, and 3 times 3 is 9, times 1 is 9. So we have 14 over 9. 9 goes into 14 one time. 9 times 1 is 9. 14 minus 9 is 5. And just rewrite the denominator, we get 1 5/9. All right? So, yes, I know what you're thinking. You're thinking, I don't like this because it's a huge amount of work. Well, nobody likes this. It's a huge amount of work. Most students, when they get into upper levels, they just use a calculator. But in this class, you have to know how to do this stuff. You have to know the algorithms. All right, so let's try another one. So, let's see here. We're going to convert this to a improper fraction. I want to convert this to a mixed number, so it becomes 3 6/10. But 6/10 just reduces to 3/5, so I'm going to go ahead and just write 3/5 to speed things up here. And again, I did 8 times 2 is 16, plus 5 is 21. That's how I got the 21, and the denominator just stays the same. All right, so I now have to convert this to a improper fraction. So I guess I'll do that in the next step. Again, we have to change everything to improper fractions or just fractions alone. So 3 times 5 is 15, plus 3 is 18, and we have 18 over 5. All right, so now we're going to, and that's 3 over 1. We have to write over 1 there. So now we're going to multiply, and we get 3 times 21 times 5 times 18 all over 1 times 8 times 6 times 5. All right, so now we're just going to continue to factor. 21 is 3 times 7, and 18 is 9 times 2, and 9 factors to 3 times 3. And the bottom, 8 factors to 2 times 2, that's 3 2s, and 6 factors to 2 times 3. So that was a big problem there. We have a lot of stuff going on there. that's just the nature of these problems. I know what you're thinking. You're thinking, why are you making life so difficult for me? Well, it's just the nature of these problems. I can't always make every problem have easy numbers to deal with. All right, so 3 down up here, 3 down there. I can cancel out those. We have a 2 up here and a 2 down here. And let's see, we have a 5 and a 5, so we can cancel those out. And I think that's about it. So now we have to multiply straight across. So 3 times 7 is 21, times 3 times 3, which is 9. So 9 times 21 is going to be 189. And you can do that off to the side if you want. And 2 times 2 times 2 is 8. So we end up with 189 over 8. So at this point, we have a huge improper fraction. So you have to figure out how many times 8 goes into 189. So let's see what happens here. We have to use the long division algorithm because we can't do that. At least I can't do that in my head. I got to do it with the long division algorithm. Subtract and be 5. And now, in order to keep going, we'd have to add a decimal. So we don't want to add a decimal because that means we're going to change it into a decimal. I would just like to write this as a mixed number. So that means we can take this 5 and bring it up, and that becomes our remainder. 23 is the whole number, and 8, the divisor, just stays, that's just our denominator. So 23, let me write that a little better there. 23 and 5/8 is our final answer. Now, we learned how to do that in the last class. The remainder is the numerator, and the denominator is the divisor, and the whole number is the quotient. That's just how you convert improper fractions to mixed numbers. But we could also keep going and write this as a decimal. So if we add a decimal here and add a 0, bring down a 0, 8 goes in 6 times, is 48, remainder is 2, bring down a 0, that goes in 2 times, 16, remainder 4, don't have room, but bring it down, and 5, and it end up 23.625. So you can also leave it as a decimal if you want. Unless, well, yeah, I was going to say unless it becomes a repeating decimal, but anyway, so what was that? That was 23 and 5/8. So that's the final answer. And I'm going to bring that down. All right. Just double checking that. Looks right. So now it's time for you to try some of these problems, and keep in mind I don't give you a lot of these problems in the homework, so don't get too worried about this. These problems are very difficult, so I only gave you a couple of these, couple of each of the hard ones. Remember, I promised not to give you more than 30 homework problems, so I'm keeping it down. I'd like you to do 200 homework problems. I would love that, because that would mean that you would know the material better. But I'm not gonna. I wouldn't do that to a person. So on to number 40. Again, we're going to convert these to convert everything to proper fractions or improper fractions, and multiply straight across. And if you keep it in factored form, it's going to be really easy to reduce. So go ahead and try number 40, and when you come back, we'll do it together. All right, we're back. So we're going to convert this to a mixed number. 2 times 8 is 16, plus 3 is 19. And then keep your denominator. The 6 is in the 10th place, so that's 6 over 10. We're going to write 5 as a whole number, so it's over 1. Then we just have to convert this to a improper fraction. So we'll just keep that there. 4 times 10 is 40, plus 6 is 46. But actually, before we do any of that, I'm just going to go ahead and reduce the 6/10. That can reduce. Whoops, that can reduce to 3/5. So now we multiply, we get 20, and then 20 plus 3 is 23. Again, that's review, changing a mixed number to an improper fraction. Times 5 over 1 times 4 over 5. So now we're ready to go. We can multiply straight across. We get 19 times 23. Ouch, that's going to be a big number. Times 5 times 4, all over 8 times 5 times 1 times 5. So we want to cancel out if we can, and we can cancel out these 5s. I see that. Actually, before we do anything, we don't have the prime factorization yet, so let's not jump ahead. So we're going to write equals, and then 19 times 23 times 5, and we can factor the 4 to 2 times 2. And 8 down here becomes 2 times 2 times 2. Again, I'm just doing the prime factorization here. So now that we have the prime factorization, we can cancel everything out at once. So 5 cancels out, and 2 2's cancel out. So the hardest part about this problem is we are going to have to multiply 19 times 23. I'm sorry I gave you a big number there. It's kind of tedious having to do that, but I can't do that in my head, so I'm going to have to do it over here. We just use the multiplication algorithm of whole numbers. 3 times 9 is 27. Carry the 2. 3 times 1 is 3, plus 2 is 5. Put your placeholder. Now I move on to 2 times 9 is 18. We can get rid of this thing we carried over here so it doesn't confuse us. 2 times 9 is 18. Carry the 1. 2 times 1 is 2, plus 2 is 3. And then we add those numbers together and carry the 1. We get 437. All right, so on the top we have 437. And on the bottom it's 2 times 5 times 1, which is 10. So we have a huge improper fraction here. So we have to use the algorithm where we take the numerator, divide by the denominator. Remember, this division, this fraction sign can also be interpreted as division. We learned that in the rates portion of the course. And we learned that in the last class. So 10 goes into 43 4 times. 10 goes into 37 3 times. And now, do we want to change this to a decimal, or do we want to change it to a mixed number? Well, if we want to change it to a decimal, we would have to add a 0 here and keep going, so we get 0.7. But if we want to add it to a mixed number, or leave it as a mixed number, what I'm going to do is just stop there, and that becomes our remainder. So this becomes our whole number, and this becomes our numerator, the remainder, and the denominator is always the divisor. So notice that the denominator stays the same. So I know that this is a lot of stuff that we're reviewing right now. It's a lot of stuff we're going over, but all of this information is available in my previous classes. So 43 7/10, or you can write 43.7. Now there's an easier way to do that. In fact, in the last class we learned that when you divide by a power of 10, you just move the decimal of this number a certain number of places. The number of places would be however many zeros you have here. So we have 1 0. When you divide by 10, you just take the decimal and move it one place to the left. So that's why we got 43.7. The decimal is not here, it's not visible, but since it's a whole number, the decimal is always one place to the right of the number in the ones place, which would be right here. So you move it one place over, it would be 43.7. And there you go. So 43.7. So that's the quickest way to do it. You're dividing by 10, you just move the decimal one place over. So there's a lot of different ways to do this. All right, going to rectangle that. So if you got 43 7/10, or 43.7, good job. So now let's do 41. Now before you do 41, I want to remind you, let's put a divider here. I want to remind you that to find the volume of a rectangular prism, volume is equal to width times height I should probably put capitals there. Width times height times length. So you have to multiply the height, the width, and the length. It doesn't really matter what order you multiply based on the commutative rule of multiplication and the associative rule of multiplication. All right, so go ahead and multiply those. I'll set it up for you. So width is 1.1. It doesn't really matter which is which. So all we're doing is just multiplying these. It's the same problem as we did before. So go ahead and attempt that problem. And when you're done, we'll come back and do it together. All right, we're back. So again, when you're multiplying decimals and fractions and mixed numbers, you have to change everything to a proper fraction or an improper fraction. So this 1.1, that is the same thing as 1 1/10. So now we have everything. We got rid of the decimal, but the problem is we have mixed numbers. So now we're going to have to change the mixed numbers to improper fractions. 10 times 1 is 10, plus 1 is 11, and keep your denominator. Just rewrite the 1/2. 3 times 1 is 3, plus 1 is 4, and rewrite the denominator. And now we're ready to go. So now we're multiplying fractions. You just multiply the numerators, 11 times 1 times 4. And the bottom we have 10 times 2 times 3. So on and so forth. And so we're going to go ahead and keep factoring, because that's going to help us. So 4 becomes 2 times 2. 10 becomes 2 times 5. And you don't necessarily have to factor completely, but I'm just doing it so you can see the full extent of prime factorization. So now we have 2's cancel out, and another 2 cancels out, and then on the top we have 11 times 1 is 11, and the bottom we have 5 times 3 is 15. So if you got 11/15, good job. All right, so those were pretty challenging. You might want to take a deep breath after those problems. Those were very, very challenging. All right, so now we're going to subtract. In order to subtract, we have to convert both these to decimals, or we convert both of these to fractions. Either method works. For multiplication and division, you have to always convert to fractions. But for addition and subtraction, you can either convert to decimals or you can convert to fractions. So 4/5 is 1.8. We've already done that before. I'm not going to do it again. So in that case, you just line up the decimals and you subtract. 8 minus 7 is 1. 1 minus nothing is 1. To bring the decimal straight down, you get 1.1. But you can also change everything to fraction form. So 0.7 is 7/10. And then we just get a common denominator. And then you subtract. So 1 minus nothing is 1, and 8/10 minus 7/10 is 1/10. So these both are acceptable answers, but you should only rectangle one probably, because you don't want your teacher to think you have 2 answers when you should only have 1 answer. All right, so for the next problem, let's try changing to fraction form, and then we can try the decimal form later. 2/10 becomes 1/5 if you want to reduce that. So now we have to get a common denominator. And we have to subtract, but we cannot subtract 5/15 from 3/15. We can't do that. You get a negative number. So we have to borrow from the 2, and it becomes a 1. And then we have to give that 1 to the 3/15. Now you can write 1 in many different forms. You can write it as 93 over 93. You can write it as 46 over 46, or 2 over 2. You can write 1 in many different forms, but we're not going to write it in just any form. We're going to write it with 15 in the denominator. So we're going to write it as 15 over 15. And why do we do that? Because we can add that to 3 over 15. So again, what do we do there? We cannot subtract 5/15 from 3/15 because we're going to get a negative number. So we borrow 1 from 2, and it becomes 1. And the 1 we borrowed from 2 becomes 15 over 15, which we add to 3 over 15, and it becomes 18 over 15. So that number then becomes 18 over 15. 1 and 18 over 15. Don't forget your whole number. Students often forget the whole numbers after they mess with the mixed numbers or change the form of them. All right, so all we did was we changed 2 and 3/15 to 1 and 18/15. It's the same thing. So now we can subtract. 1 minus 1 is just 0, and 18 minus 15, 18/15 minus 5/15 is 13/15, and that's the answer. Again, the ones just went away because they were subtracted. 18/15 minus 5/15 is 13/15. So everything that we did is just review. The only difference was we had a decimal. We didn't, or we're combining. We're combining decimals and fractions. We haven't done that before. But it's after we changed the decimal to a fraction, then it was easy. We've already done this stuff before. Not exactly easy. You're going to have to review some of this stuff, but you get the point. Now in this case, you're probably thinking, well, okay, well, what about changing to a decimal? Because we tried both methods. We tried changing to decimals and changing to fractions. Why can't we try changing both these to decimals? Well, we can't do that because this is going to be a repeating decimal. You can't subtract a normal decimal from a repeating decimal from a normal decimal without learning some things that we haven't gone over yet. You're going to learn that in the next math courses or sometime in your education. All right, so let's see here. Actually, you'll probably never learn that, to be honest with you. That's not really part of the curriculum. It's not that it's difficult. It's just for some reason it's never taught. So on to the next problem. Now we're dividing. Whoops, I forgot to erase that. So let's do a couple of division problems. Division is the same situation as multiplication in the sense that you just have to change all these to improper fractions or regular fractions. So we're going to change this to 8/7, and we're going to change this to 3/10, and there you go. I'm kind of going fast through this because we're running out of time. So now we have to go back to the division algorithm for fractions. So if you recall, to divide fractions, you just change to a multiplication sign and you flip the divisor, so that becomes 10 over 3. Then it's just a regular old multiplication problem. You multiply straight across, and the numerator and the denominator, 8 times 10 is 80, and 7 times 3 is 21. Now I'm not going to keep it in factored form because you have 7 and 3 in the bottom, and you have just a bunch of 2's and a 5 on top if you factor these, so you can't really cancel anything out. So we have one big problem. What's the problem? Well, we have an improper fraction, so we have to figure out how many times does 21 go into 80. It goes 3 times. 3 times 21 is 63. You can do that off to the side if you want, but I just did it in my head. So 80 minus, and you'll get, as you get used to this stuff, you'll be able to do this stuff in your head also. So 63. So 80 minus 63 is 17. That's the remainder, and the denominator is just written. It's just same denominator. All right. So why don't you try number 45, and when you come back, we'll do it together. All right, I should have left you this problem. You didn't, so you could see this problem there. All right, so change everything to fractions. That's 1 and 5/10, and we can go ahead and reduce that to 1 and 1/2. And now we have a mixed number that we need to change to an improper fraction. Remember, when you're multiplying or dividing improper fractions, you have to change them to when you're multiplying and dividing mixed numbers, you have to change them to improper fractions, so you get 3/2. Whoops, sorry. 3/4 divided by 3/2. And then, to divide fractions, you just change the division sign to multiplication, flip the divisor, multiply straight across, and you get, I'm going to keep it in factored form because I see that we can factor stuff here. And I'm going to do the prime factorization because we have a 4 down there that can be factored even further. And I'm going to move this stuff over because we're running out of room here. And you can see that we can cancel a 3 and we can also cancel a 2. And you're probably thinking, okay, well, there's nothing left in the top, so we write 0. But remember, there's always a factor of 1. So it's not going to be 0 on the top, it's going to be 1. And the bottom is going to be 2, so we have 1/2. So if you got 1/2, good job. All right, so now the last thing we're going to do today is multiple operations with fractions and decimals. So because we have multiple operations, we have to use, you guessed it, Pemdas. Pemdas says parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. All right, so we're going to do the parentheses first here. So 1/4 plus 1/2. We get a common denominator. Multiply both these numbers by 2 and you get 2/4. So these problems are going to take a while because we're going to have to write all these steps out. 1/4 plus 2/4 is 3/4. So 3/4 is still raised to the second power. Now we're going to have to raise 3/4 to the second power. Now, I don't remember if we've actually done that. Raising something to the second power, we've done that, but we haven't raised a fraction to the second power. I don't recall. So, for example, if you have 3 to the second power, that just means 3 times 3, right? So now we have 3/4 to the second power, so that means 3/4 times 3/4. To multiply fractions, you just do 3 times 3 is 9, and 4 times 4 is 16. So that would just be 9/16. All right. So now we just add the whole numbers. Actually, wait. No, we got to multiply first. So remember, now we did parentheses first, and then we did exponents. I didn't mention that. Parentheses first, then we did exponents. I should go back to my Pemdas thing here so we know what's going on. Now we have to do multiplication, which is this part. Do not add first. We have to multiply first. So we have to multiply 9/16 times 2. So in order to multiply a fraction by a whole number, we have to write the whole number over 1, as we discussed earlier. And now we just multiply straight across. 9 times 2 is 18. 16 times 1 is 16. And just rewrite the other part. So it's becoming simpler and simpler now. So we can reduce the 18 over 16. That reduces, divide both sides by 2, and you get 9/8. And so now we have a decimal and a whole number and an improper fraction. So there's a lot of different ways we could do this, but let's see. I think the easiest way would be to use fractions. So 2 plus, and we're going to change this to a mixed number. So 8 goes into 9 one time. The remainder is 1. Rewrite. And then 3.4, that becomes 3 4/10. And we don't have to reduce the 4/10. So add all the whole numbers together, 2 plus 1 plus 3, and you get 6. And then we have to add, actually before we do that, we should get common denominators. So the common denominator is going to be 40. So multiply both sides of 1/8 by 5, and you get 5/40. And then multiply both sides of the other fraction by 4, and you get 16/40. So now we add all the whole numbers to get 6. 2 plus 1 plus 3 is 6. Then 5/40 plus 16/40 is 21/40. And I don't think we can reduce that. So 6 and 21/40. So again, I know what you're thinking. You're thinking, I don't want to do that. That's too much work. Well, I understand it's a lot of work, but don't be too worried about it because the class is almost over. This is probably one of the hardest things I'm gonna make you do in this entire class. So just try to get through it. This is helping you review a lot of different things. We have 1, 2, 3, 4, 5 more problems, and I don't think we're going to get to the end problem, so we're just going to probably do a couple more here. So why don't you try number 47, and when you come back, we'll do it together. All right, we're back. So you have to do parentheses first. So I'm going to go through this a little fast here because we're running out of time. So we have to write the 3 over 1, or else we can't multiply. So now it's 3 over 1. So now we multiply straight across. 3 times 1 is 3, and 2 times 1 is 2, and it's still squared. So now we do exponents. That's the e part. We did parentheses. Now we do exponents. Maybe I should move my Pemdas thing down here. So 3/2 times 3/2, that would just be 9/4. And now Pemdas tells us to do division next. So we have to do this part. 3/5. When you're dividing fractions, you change to multiplication and flip the divisor. So this flips. All right, and multiply straight across. So when you multiply, you just do 3 times 3 is 9. 5 times 2 is 10. And now we have an interesting situation. We have addition and we have subtraction. Remember, Pemdas tells us that when we have addition and subtraction, we have to move left to right. That's what the arrow tells us, move left to right. If you don't move left to right, you'll get the wrong answer. If you add these first, then subtract from this, you're going to get an answer that's way off. We have to move left to right. We have to do this part first. Then once we get that, we'll add it to this part, and then we'll add it to the 6, and so on and so forth. So first we have to do 1.2 minus 9/10. So I'm going to actually, let's see, I'm going to change all these to decimals. I think that would be easier. So 1.2 minus 9/10, that's just 0.9 if you recall. And then 9 over 4, that's going to be 2 1/4. So I had to change this to a mixed number first, then I'll change it to a decimal. 4 goes into 9 2 times, and the remainder is 1. And just rewrite the denominator. So now we have 1.2 minus 0.9 plus 2 1/4. Now we already figured out that 1/4 is 0.25, so I'm just going to add that 0.25 there. But again, you just take 1 and divide by 4 using the long division algorithm, as we said a million times today already. All right, so now we have a bunch of decimals and we're ready to go. So we have to line up the decimals. Wait. Yeah. So we're going to do 1.2 minus 0.9. We have to do that first. That's the most important thing to understand. We have to do that part first. The arrow tells us to do that part first. So 2 minus 9, we cannot do that. We have to borrow from the 1, becomes a 0, and give the 1 to the 2, it becomes 12, and 12 minus 9 is 3. Bring the decimal straight down, you have 0.3. So I realize I'm doing this kind of fast, but again, this is all review. So now that we have addition, we can actually just do all that part at once because it's all just addition. So there's not going to be any confusion there. The important thing was to do this part first. That's where we get into trouble if we don't go left to right. And remember, the 6 goes here. The decimal is there because it's invisible. It's got to go one place directly to the right of the number in the ones place, which is 6. Add the numbers up and you get 8.55. So if you got 8.55, that was a pretty good achievement there, because that was a long problem. All right, let's see here. Something's not right here. Let's see here. What did I do? Oh, yeah, that's right. I thought I did something wrong, but that looks good. All right. So we have just a few more minutes here, so we got to get this stuff done. So now we just have addition and subtraction of fractions and whatnot. Actually, I think I meant to make that actually, no, that's right. So now we want to use the order of operations agreement with addition and subtraction. Notice we have addition and subtraction in both these remaining problems here, and we have multiplication and division in these remaining problems. So the purpose of these problems is to show you the arrow part of the order of operations, which we actually already demonstrated here. We had to do those operations left to right. So we're not going to have time to get through all of these, but basically you want to do this part first because you have to move left to right, and then you can add this number. That's the key. So we're just doing fractions and decimals with order of operations. So I'm going to do this kind of fast. So we have 35 over 40. And we have 32 over 40. Now we have a common denominator. But we have to do this part first. So 35 minus 32 is 3. So we have 3 over 40 plus 11 over 40. Then we can add them together and get 14 over 40, which we can reduce, divide both by 2, and you get 7 over 20. So again, the whole principle there is you have to do this part first, because when you have addition and subtraction, you have to move left to right, or else you're going to get the wrong answer. Now, if you add these two together, then subtract that from 7/8, you're going to get the wrong answer. All right, so the same situation here. Actually, in this case, you wouldn't really get much. You wouldn't get in trouble. We don't have time to do that one. So let's go down to the division and multiplication. In this case, you would not get into trouble, but in this case, you would get into trouble. So let's do. We have time to do 51. So that'll probably be the last problem. So again, it's just the same thing that we did before. The only difference is we have multiple operations. We have division and multiplication. So because we have division and multiplication together, we have to move left to right. Okay, if we multiply these first, then divide by this number, we're going to get the wrong answer. So we have to do this part first. When you're multiplying and dividing, you got to convert everything to improper fractions or proper fractions. So we convert this to 17 over 5. And then we convert the 4/10, or the 0.4 to 4/10. Then we can reduce 4/10 to 2/5. And now here's where the important part comes in. We have to do this part first. So when you're dividing, you change to multiplication. When you're dividing fractions, you change to multiplication and flip the divisor. So 2/5 becomes 5/2. And we're going to do this part first again. So, well, actually, at this point, we just have one operation. We just have a bunch of multiplications. So when you have multiplication operations, multiple multiplication operations, or multiple addition operations, you can add or multiply in any order. That was the associative rule of multiplication, and that was the commutative rule of multiplication. This does not apply for subtraction and division. And sorry, I'm talking fast, but I don't want to go too long here. So anyway, we just multiply straight across, and we get 17 times 5 times 1 over 5 times 2 times 6. But 6, I'm just going to write as 2 times 3. So we just have one thing here that can cancel out. And on the top, we end up with 17 times 1, which is 17. And the bottom, we have 2 times 2 times 3, which is 12. That's an improper fraction. 12 goes into 17 one time, and there's a remainder of 5. And just rewrite the denominator. So 1 and 5 12s. I think we have time to do one more of these. Actually, why don't you try number 50, since we did multiplication and division just now, and when you come back, we'll do it together. All right, we're back. So everything is already a fraction at this point. And it turns out that in this problem, it doesn't really make a difference what you do first. You're going to get the same answer no matter what. Let's see here. And then that becomes, but we should just keep the rule here. So we're going to multiply these together first. 4 times 3 is 12, and 7 times 8 is 56. Actually, I'm going to keep that in factored form so I can factor it. So 4 times 3 over 7 times 8. So we did that. And so again, I'm just keeping it in factored form. So 4 times 3 over 7 times 8, and now we're going to divide, so we have to change this to multiplication because we're dividing fractions, and flip the divisor. And now we're just going to multiply straight across. So 4 times 3 times 5 over 7 times 8 times 1. And 4 becomes 4 times 2. Excuse me, 4 becomes 2 times 2. 7 becomes 2 times 2 times 2, or 8 becomes 2 times 2 times 2. I'm talking too fast here. And 2's cancel out. Another 2 cancels out. And 3 times 5 is 15. And 7 times 2 is 14. So we have an improper fraction. 14 goes in one time, remainder 1, and keep your denominator. So I think that's all we have time for today. We did quite a bit, and that was a lot of work. I realize that's a lot of work, but don't worry, because the course is almost over. So if you got this far, you're doing good. So here's the homework. Remember, if you have repeating decimals, you have limits as far as what you're capable of doing. So take a screenshot of these 2 pages. Take a screenshot of these 2 pages. You have the answers, as usual. If you come across repeating decimals, just remember you can try something else, because sometimes repeating decimals we can't deal with. So that was class 34, and I'll look forward to seeing you in class 35.